Hi everyone, let's go through a chapter on relations and functions, and in this video we will cover Cartesian products. Before going through relations and functions, we will have to understand some basic terminologies such as ordered pairs, equality of ordered pairs, Cartesian product, etc. So what is an ordered pair? Ordered pair is nothing but a pair of elements like this, A comma B. So where A is an element, B is an element, A belongs to set A and B belongs to set B. So A and B are sets. The small letter A and small letter B are the elements in these sets. A is the first element and B is the second element. So here the order matters, right? A comes first and B comes second. That's why it's called as an ordered pair. What is equality of ordered pairs? Equality of ordered pairs means, suppose we have two ordered pairs, A comma B and C comma D. We can say that this pair and this pair is equal only if A is equal to C and B is equal to D. Only then we say that these two pairs are equal. What is a Cartesian product? Cartesian product, suppose say we have two sets A and B. Let's say set A is having elements A, B and set B is having elements C, D, E, right? So Cartesian product would be represented as A cross B, A into B or A cross B. Now, let's say this is set A with two elements A and B and set B with three elements C, D, E. So what you'll do is you'll take the first element in set A, say A, and then pair it up with all the elements of set B. That is, you pair A with C, A with D, A with E, right? So you have three pairs, A comma C, A comma D, A comma E. So now you'll go with the second element, which is B, this one. And now you'll pair B with all the elements of set B. B with C, B with D, B with E. So B comma C, B comma D, B comma E. Now if you look at this, you have 6 pairs, 1, 2, 3, 4, 5, 6. All these 6 pairs together is called as Cartesian product. Cartesian product, that is A cross B or A into B, right? So now let's take an example, right? Say set A is having 3 elements and set B is having 2 elements. We'll have to find A cross B and B cross A, right? Both of these are not same, right? Let's verify that. Let's find out A cross B. A cross B is, now let's write the ordered pairs, right? So you take first element A. Let's take first element A with C. Then A with D. Now we'll go with the second element B. B comma C and B comma D. Now we'll go with third element C. C comma C and C comma D. So now we have finished taking all the elements of set A and we have paired it with all the elements of set B. So this is the Cartesian product. This is A into B, right? Now similarly we'll find B into A. B is equal to C comma D and A is equal to A comma B comma C. Now we will have to write set B first and then set A because we have to find B cross A, right? So now we'll start creating ordered pairs. We'll take first element C, C comma A, then again C comma B, then C comma C. Now we'll go to the next element D. D with all these elements, D comma A, D comma B and D comma C. So we have covered both the elements from set B and paired it with all the elements of set A. So this is B cross A. Now if you notice, the ordered pairs are not same. This is A comma C and this is C comma A. These are different. That's why it's called as ordered pair, because the order does matter, right? These two are not same. Now let's take another example where set A is given, set B is given, set C is given. We'll have to find A cross B union C. We have to find A cross A into B union C. So first we'll have to find out what is there in brackets. Always brackets take a precedence. Remember the Bodmer's rule, right? Bodmer's rule is first it's brackets that takes precedence over division, multiplication, addition, subtraction. So let's cover what is there in brackets. In brackets you have B union C. So what is B union C? B union C is take all the elements of B and all the elements of C, right? So you have 2 and 3 in B and in C you have 3 and 4. 3 is already there, so we'll put 4, which will be non-repetitive. Now we'll do A into B union C. That is, what is A? Let's write set A. Set A is 1, 2 into B union C, which is 2, 3, 4, which we got here. Now, we'll have to find the Cartesian products because there is into here. We'll start with first element 1 with all these elements 1, 2, 1, 3, 1, 4. So we finished 1. Now let's go to second element 2. 2, with all these elements 2, 2, 2, 3 and 2, 4. So this is A into B union C. Now we'll find the second one, which is A into B and A into C. Now we'll find A into B first, A into C first, and then take a union of these. So A into B is nothing but, let's take first element 1, 1, with these elements 2 and 3. 1, 2 and 1, 3. Now we'll go with the second element 2. 2 with 2 and 3. 2, 2, 2, 3. So we have A cross B. Now we'll find A cross C, A into C. So A into C is, we'll have to take this set and this set, right? So 1 with 3 and 1 with 4. The next one is second element, which is 2. 2 with 3 and 2 with 4. So now we have both of this. Now we'll have to take union between both of these. That is, A into B and A into C would be union of these, right? So let's write down all the ordered pairs 1, 2, 1, 3. Let there be no repetition, right? So 1, 3 is already there. So let's ignore that. 1, 4 is not there. 2, 3 is already there. 2, 4 is not there. This is the answer for A cross B into A cross C. Now let's take the third example. Set A is given, set B is given. We'll have to find A minus B into A and A intersection B into B. So let's take first one, A minus B into A. Let's first find out what is there in brackets. We have A minus B. So A minus B means elements that are there in set A but not in B. Elements, A minus B means elements that are in set A but not in B. So A minus B. So element is there in A but not in B. Let's take first element A. Do we have A in B? No. So A will be here. B is not there. So B also will be there in this set. C is not there. D is there. So we don't have to put that, right? So basically elements that are there here in set A but not in B. Not in B. So we have A minus B. Now cross product into set A. Set A is A, B, C, D. Now we'll find the Cartesian product. Cartesian product is, take the first element A, A. We'll do it with all 4 elements. A, B, A, C and A, D. Now let's go with the second element with all 4 elements. B, A, B, 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 C and B, D. Now let's take the third element. C, all this. C, A, C, B, C, C and C, D. So these are the ordered pairs. This is the answer for this particular first example. Now let's find the second one. Second one is A intersection B into B. Now we'll first find A intersection B. We have to start from left side. So whenever you have something like this, the order would be start from the left side, right? There is no brackets here. A intersection B. What is A intersection B? A intersection B is nothing but the common elements between set A and set B. What are the common elements? The common elements are D only. So D into set B. Set B is D, E, F, G. Now let's find the Cartesian product. Let's take the first element D, 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 E, D, F and D, G. So this is the Cartesian product. Now let's take fourth example. Set A is given, set B is given, set C is given. We will have to verify this particular statement. So let's start with left hand side first. What is there on the left hand side of the equation? Left hand side is A into B minus C. What is there on the right hand side of the equation? Right hand side of the equation is A into B minus A into C. So basically you will have to first take the left hand side, work out this entire thing, then take the right hand side, which is this one, work out this entire thing and check if both the results are same. If both the results are same, then this particular statement is true. So let's start with left hand side. Left hand side, we'll have A. What is set A? Okay, first thing is we'll have to solve what is there in brackets. What is there in brackets? B minus C, right? For now, I'll write set A as is. I'll substitute, instead of A, I'll put set A into B minus C. What is B minus C? Elements that are in B, not in C. Elements in B, not in C. Now let's come to B, set B. You have D. D should not be in C. It's not there. So D, that's all. Now we'll find the Cartesian product. So we'll take first element, second element, third element with this element. So A with D, B with D, and C with D. That's all. This is LHS. Now let's call this as, say, equation 1. Let's come to the right hand side, RHS. RHS is equal to, let's first, since the brackets are there for this one and this one, both are important. But when there are two things which are of equal importance, you start from left to right. You start from left to right. So left side you have A into B. So A into B. Let's get the ordered pace for A into B. Let's take A, B, C with D. A with D, B with D, and C with D. Now we'll find A into C, right? A into C, that is with this particular set and this set. So let's take first element with set C. A, E, B, E, C, and E. Now this minus this. So what does this mean? Pairs that are there in this set. Pairs that are there in this set but not in this set. Pairs that are there in the first set but not in the second set. Now AD, is it there? No. Let's put AD. BD, is it here? No. So let's put BD. CD, is it here? No. CD, that's it. So this is RHS. Now let's call this as equation 2 or expression 2. Now you compare 1 and 2. AD, AD, BD, BD, CD, CD. Both are same. Both the sets are same. Therefore, from 1 and 2 we conclude that LHS is equal to RHS, which means this particular statement is true, is proved. Let's take the fifth example. Set A is given, set B, set C is given. Find A minus B into B minus C. Now here this is tricky. Set A is not given, but the expression is given. Set A is not complete. An expression is given. We have to find the elements of this particular set A. Now they've given a quadratic equation. First let's get this set correct. They've given the quadratic equation, which is x square minus 7x plus 12 equal to 0. Now you have to find the values of x. Only if you find the values of x, that values you can put in this particular set A, right? How do you find the values of x? There are two methods. One is sum product method and second one is using formula. Now let's go with the second method, that is using formula. So if you have any equation like this, ax square plus bx plus c is equal to 0. If you have any equation like this, then x, value of x would be equal to minus b plus or minus root of b square minus 4ac by 2a. So this is the formula to find the value of x. Now you will have to take this entire expression with plus and another expression with minus. So when you apply plus and minus to this entire expression, you will get two values of x, right? Now what is a, b and c? A, b and c is the coefficient. It is a number that is adjacent to x. So a is the coefficient of x square, b is the coefficient of x, and c is a constant, right? Now let's use this formula here. What is the equation we have? X square minus 7x plus 12 equal to 0. Now x is equal to, what is a here? There's nothing here. A is actually coefficient of x square. That is a number next to x square is a. Now there is nothing here. There's no number, which means it is 1. So a is equal to 1. What is b? B is number next to x. Next to x. It's minus 7. Remember to take the minus sign. And what is c? C is just a constant. That is just the number. C is equal to plus 12. Now substituting a, b and c, we'll find value of x. X is equal to minus b. Minus b, that is minus 7, plus or minus root of b square, that is minus 7 the whole square, minus 4 into 1 into c is 12, divided by 2 into A, right? Now, what do we get? Minus into minus is 7, plus or minus. Minus 7 the whole square is 49, minus 12 fours are 48 by 2. So this will give us x is equal to 49 and 48 is 1, root of 1 is 1. So you'll get 7 plus or minus 1 by 2. This is nothing but x is equal to 7 plus 1 by 2. X is equal to 7 minus 1 by 2. So we'll have to take one expression with plus and second expression with minus. 7 plus 1 by 2, 7 minus 1 by 2. So you'll get 8 by 2 and here you'll get 6 by 2. So this will get cancelled, you'll get 4 and this will get cancelled, you'll get 3. So you have two values of x. X is 4 and 3. So what is set A now? Set A is 4 and 3. Let's proceed with solving this. So these are the three sets that we have, right? Now let's take the statement. Find A minus B into B minus C. This is what we have to find. So A minus B, elements in A but not in B. 4, it's there. 3, it's not there. So this will be 3 into elements in B but not in C. Elements in B but not in C. Is 2 there in C? No. Is 4 there in C? Yes. So let's not write 4. So now let's find the Cartesian product. Simple. 3, 2. So this is the answer for this particular problem. Now let's take sixth example. If U is equal to this, that is this U is nothing but universal set. If set U as these elements A, B, C, D till G, that is E, F, G, and set A is given, set B is given, set C is given, find this particular set. A intersection C, complement. B minus C, the complement in U. So let's take the first one. A intersection C, the whole complement in U. So with respect to U, that is with respect to this particular set, you have to find A intersection C, complement of A intersection C. This is called as the complement. Complement. Let's first find out what is there in brackets A intersection C. What is A intersection C? Common elements between set A and set C. So CD are common elements, right? So you'll have CD. Complement of this in U. Now, complement of this with respect to set U. This means elements in U which are not in this set. Elements in U which are not in this set. So, C and D you eliminate here. Remove C and D. All the other elements in U. What are the other elements in U? You have A, B, E, F, G. So, this is the first one. Now, let's find the second one. Second one is B minus C, the whole complement in U. So, let's find B minus C first. Elements in B but not in C. Elements in B but not in C. B is here? No. D is here? Yes. F is here? Yes. G is not there. So, B and G, complement of this in U. This means elements in U but not in this set. So, leaving these elements, all the other elements, ignore these elements BG, ignore B and ignore G. What do we have? A, C, D, E, F. So, this is B minus C complement in U. With this, we have come to the end of this particular topic. Thanks for watching. Hope this video was useful.